And then you'll see down here conceptual types or schematic types. We're not going to use schematic types, okay, or detailed elements, because we're in a conceptual modeling mode. So we're going to go to edit conceptual. And if we look here, then we're going to see right now what our different conceptual surfaces are set to. Okay. If we look at the code, okay, once again, the code actually has some requirements to that. And if we go to this particular table in the commercial code, we'll see that it's defined by different climate zones. San Antonio is in one climate zone. It's in 3 high humidity. So it's in climate zone 3, and you'll see insulation entirely above the deck, that the roof should be at least an R20 is requirement by code. And then metal framed walls, which most likely is what this would be. And if we look at the group R is residential, all other is all other commercial. You will see R13 plus a 6.5 continuous insulation, which is basically an R20 on the walls. I'm sorry, yeah, an R20.5 on the walls right here, metal framed. And then a grade wall, no insulation required. And then we see floors. If we have mass floors, we need R10 continuous insulation. And if floors that are exposed to the exterior, which we don't have any, is not important. And then unheated slabs. Okay. If we look at then the material properties in these conceptual models, this is taken from the knowledge base of Autodesk. If we look, you'll see lightweight construction is an R25 with high insulation. Lightweight construction, typical cold climate. And you'll see lightweight construction, mild climate. Well, we're a relatively mild climate, but code requires that we have a much higher R value in our walls. As a matter of fact, an R20 on our walls. So I'm going to use the lightweight construction, even though that's the most high insulation, because once again, it's closer to what code would require us to have, and there's no sense in kind of cheating by using a lower value. You'll see mass exterior walls, and we don't have any mass exterior walls. And then you'll see roof IP. You'll see 2 levels of roof. A cool roof, which is definitely what we want in a hot climate, both for Lubbock or San Antonio, whichever site you're using, and which would be an R22. So, and then an R32. Let's see. Let's go back here. To the IECC group 3 roof was what? An R20. Okay, so R22 meets that, so we'll use typical insulation cool roof as a default. And then floors, you know, we'll just probably go with lightweight construction, typical. I don't see where floors would be, well, if it's a raised floor, you know. But mass slabs, R value 1611, high mass construction, no insulation. Okay, that insulation isn't required in that particular climate zone, so we'll use a high mass, no insulation. And then glazings here. If we go back to the IECC, there's another table here about glazings. You can see fixed fenestrations, and you'll see climate zone 3, and you'll see 0.46, 0.60, 0.77 for entrance doors. So we're going to use 0.46 U value. That's a U value. The solar heat gain coefficient should be at least 0.25, and and this is of course skylights down here. Okay, and this is vertical fenestrations. So 0.46 and 0.25. So let's go back here. 0.46, double pane reflective, double pane tinted. Well, they really don't have a window that meets those particular specifications. Either we're going to short the cold climate, high performance, low E, high TVIS, low solar heat gain coefficient. That meets the solar heat gain coefficient, but this is a lot more insulating window. We need a 0.46, and of course in U values, the lower the better instead of the higher. This is 0.29, so we're just going to use this one. High performance, low E, yeah, that's got at least the solar heat gain coefficient that we need. Okay, and then the interior walls, mass skylights, and so that's going to be it. I'm going to go back here and look at material and thermal properties, and if we go down to glazing, oh yeah, we already decided double pane clear, high performance. Okay, so let's go in here and kind of readjust these based on the code. We determined that lightweight construction, high insulation was required to meet code. Interior walls, lightweight construction, no insulation, that would meet. Mass exterior wall underground, we don't need high mass. Technically, we don't have to insulate. Mass roof, typical insulation. Cool roof, I think that's correct. Typical insulation, and then cool roof. That's an R22, which gets us into. And with a cool roof, that means it has a reflective surface on the roof, so that heat is reflected more effectively. Mass floor. I don't think we have any mass floors, but I'm going to put a lightweight construction. And when it refers to mass here, it's not talking about the density, it's talking about the floor construction. And so that would be the insulation between one part of the building and another. We'll just set that to no insulation. Mass slab, once again, we're not required to have any insulation. And then mass glazing here, we talked about double clear, low, high, double pane clear, low E, hot climate. So here we're going to use that with a low solar heat gain coefficient. And then basic shade, this has to do with objects in the scene. And then double pane clear for skylights. We're not using skylights, so it really doesn't matter. But we might go ahead and set this. We would never want to use something that that low a performance. Since we got a hot climate, we'll just go ahead and set that to that. So now we've set up all of the conceptual materials, so at least they mirror to some degree what code requires to do. If we choose lower performing materials, then we're really kind of cheating on this, because what we want to see is if we meet code, how's our building going to perform? Okay, and so I'm going to say okay to that. I don't know, for some reason that reset itself, and I'm going to set this back to 30 as we did before. Perimeter zone, first floor is great. Okay, let's make sure this didn't reset. Yes, okay, that's good. And so we're going to say okay, and then we're going to say okay again. And our energy settings now are all ready. And so in the next video, I'm really going to start to cover how you do the energy analysis, which is really a pretty easy, short process, but I'll do a separate video on that.